Secondary or auxiliary memory. We have spoken about the RAM or the main memory in the prior session. Now we shall talk about secondary or auxiliary memory. Examples of secondary or auxiliary memory are your hard disk, pen drives and so on. The advantage of secondary memory is it is non-volatile. In the sense, data and programs do not get lost when the power is switched off. That means they can be stored permanently. Examples of devices, as I mentioned, are hard disk, DVD, magnetic tape, pen drives and so on. I give you an example. I told you if a PC contains say 8 GB of RAM, it would easily have 500 GB to 1 terabyte of hard disk space. So if you look at it, the capacity of the main memory is much lesser as compared to that of the secondary or the auxiliary storage. Now, in order to read from the secondary storage, since most of the time it's an electromechanical device, it requires more time than reading from a RAM. The average time required to read or retrieve data from a storage device is known as access time. What is this access time? There is something called as a read-write head. So this you can think of your read-write head. Suppose the data is C here, my head is here. To take it to C, it takes a certain time. So that is the time required to position the read-write head onto C. And then it takes certain amount of time to transfer the data or write the data to this particular location. So that is known as the access time. What we shall do is, we shall now take a look at the hard disk, how it really looks internally, and try to give you a brief idea of its organization or structuring. So carefully take a look at it, then I'll help you understand it. So this is a schematic or a diagrammatic representation of what is inside your hard disk. This is not outside your hard disk. So here if you look at it, these are a number of metal plates. So you can think of like your food plates, a number of them. They could be 18, 20, 24, 60 or whatever number of plates. On top of this plate, it is coated with magnetic oxide. Now magnetic oxide, you can record data on the magnetic oxide tape. Or whatever magnetic oxide data is there, you can record data on that particular thing. Now in order to read and write data from that plate, you have a head. Now since I told you it's not one plate, it's got multiple plates. Below and above every head there is a below and above every plate there is a read-write head. So the read-write head allows you to read and write data from these plates or platters. So let me re-simplify it for you. It consists of a number of plates stacked one upon the other. You can think of it like when you go for a marriage on the buffet, they have kept a number of plates on that. So you can think of it like that. So that you call it as platter. The top and bottom are coated with magnetic oxide. Then you use the read-write heads which is on top as well as bottom of every plate so that you can read faster. Now these plates are rotated about the spindle. The average speed of rotation is between 5400 to 7200 revolutions per minute. At high speed it can rotate, so you can read data fast. I'll tell you what is semi-random. Now suppose if I ask you to find the word both on this particular item here, on this particular area of the page, you will start reading from like this and you will say okay, both is here. Now you have to start reading from beginning till you reach both. This is sequential access. But if you have looked at your phone book, it is organized alphabetically. A for somebody's name, B somebody's name. So looking at B, you can go and look at all the names of starting with B, or all the names ending with X, all the names ending with P, all the names ending with S and so on. So that is called semi-random, because when you go to B, X, Y, A or D, you don't get the name. From there you have to again start searching in a sequence. So that is known as a semi-random access device. I had already told you data is recorded on both the sides of the plate. Then you have many read-write heads so that you can read and write faster. Now you need to understand how data is organized in this particular hard disk. If you look at this, this is the complete track. So it consists of a number of tracks. You can think of this like your stadium. where you have a number of circular tracks. Now this track is divided into subdivisions called as sectors. So the concentric circles are tracks. This subdivision of tracks happens to be sectors. Okay, tracks are further divided into sectors. So the basic amount of data or sector is the basic unit of reading and writing data from the hard disk. So let's try to take a little bit more in detail here. So if you look at it here, this complete thing in red represents one track. This B here, just this B, just this small portion B, not the complete blue, just this outer one B represents a sector. Now, if you look at it, this is 0 track, 1 track, 2 track, 3, 4, 5, 6, 7, 8, 9 tracks. So these are all tracks. All these are tracks. Now, if you look at all the sectors in along the tracks, that is known as the track sector. That means the sectors which are all along all the tracks, that is one sector which is common to all the tracks. That means these are going to be multiple sectors belonging to multiple tracks. And finally, you have cluster of sectors. On the same track, if you have more than one sector, that is called as a cluster of sectors. So I hope you had a brief idea about what is a secondary or auxiliary device, that is a hard disk, how data is organized in this, and how the hard disk is organized so you are able to read and write. A lot of the other parts are not really too important. You need to understand how the data is really organized.